All right, and now for the second type of graph, we'll talk about a velocity versus time graph. For this graph, the slope represents something as well, but it's not velocity. So on the first graph, on a position versus time graph, the slope represented velocity. Everything for this graph, all the answers that we need for all the questions we're ever going to have are going to come from the slope. This graph is different. The slope does represent something, and we'll talk about proving this later. Well, I can prove it now, it doesn't matter. The slope represents acceleration. And the proof of that is that if we calculate the slope is change in y over change in x. The y variable is velocity, and the unit for velocity is meters per second. The x variable is time, unit for time is second. So the units we would get for that is meters per second. And if you algebraically rearrange it, you get meters per second squared, which is the unit for acceleration. So that's the same sort of proof that we went through for the slope of a position versus time graph. And if you don't understand that, that's okay. Just understand that the slope represents acceleration. However, knowing that is not going to be nearly as beneficial with this graph as it was up here. So knowing that the slope represents velocity on this graph is really, really important. Remember we said that these two, literally these two words can be interchangeable. They switch places. Not the case here. So first of all, as we begin to consider this graph, we also need to understand that there's a negative side to it. There will be negative numbers down here on every velocity versus time graph. Important to understand that. And there is also a key to analyzing this graph. There's something that we're going to look at 99% of the time. So on this graph up here, the key was the slope. Down here, the key is no longer the slope. The key for this graph is actually the y value. And a lot of people hear that and they go, oh man, how am I going to remember that? How am I going to remember that difference? Well, here it is. The key for this graph is the slope. The slope represents velocity. Key for this graph, y value. Y value represents velocity. So on both graphs, we're going to primarily look at whatever represents velocity. And on the velocity versus time graph, the y value is velocity. Because we're looking at the y value, actually these questions aren't going to give us much information. So we're going to scratch out the word slope. And instead of looking at what the slope tells us, I want to know what the y value tells us. I want to know what the y value tells you. So the y value is going to give us three important pieces of information. Hint, hint. The slope gave us three important pieces of information for the position versus time graph. And they're actually the same exact pieces of information. So number one, the thing we can tell from the y value is the direction of motion. And I can tell the direction of motion based on whether the y value is positive or negative. So we're writing the same words for this, but realize we're not looking at the same thing. So in the first one, we were looking at whether the slope is positive or negative to determine the direction. It's really important to understand that on this graph, we really don't care about slope very much at all. It's all about y value. So here it's not whether the slope is positive or negative, it's about whether the y value is positive or negative. And that's actually a little bit easier because everything up here, positive y value. Everything above the x-axis. It doesn't matter what the line looks like. It doesn't matter what the slope is. If the line is above the x-axis, we have positive direction, positive motion. And everything below the x-axis, everything down here, negative direction, negative motion. So we can look at the direction of motion from the y value. We can also tell the actual speed from the y value, the number of the speed, the magnitude in other words. We could tell that in this graph as well. We could tell the speed from this graph, but in this one we had to actually calculate the slope because the slope represents the speed. This one it's easier. We don't have to calculate anything. All we have to do is read the graph. Right? So for instance, I might ask you, what is the speed of this object at 10 seconds? Well, all you have to do is go up to 10, go over here, and it's probably around 7.5 to 8 meters per second. Let's just assume that meters per second is the unit here. All you got to do is read the graph to find the speed. So we can find the direction of motion by determining whether the value is above or below the x-axis. We can find the speed by actually just reading the graph, knowing what the y value is at that point. And the third thing we can tell is if the speed is constant or changing. Constant, sorry about my writing. We can tell if the speed is constant or if it's changing. Now up here, we were looking at constant speed versus changing speed based on whether we had straight lines or curved lines. So straight lines, constant speed, curved lines, changing speed. No longer the case for this one, because this is all about slope. This is all about velocity. So we're looking at this is all about y value. We're looking at constant y value versus changing y value. This y value is changing because it was 2, now it's 4, now it's 6. So we have changing y value here. This one happens to be increasing speed. If it's a constant y value, it's simply going to look like this. It's going to be straight across like that. So at the bottom, a couple of questions that are important to consider. How can we tell if the object is moving? Same two questions as we had up here. How can we tell if the object is moving? And the answers are actually going to be exactly the same, except for now we're talking about the y value instead of the slope. So how do we know if the object is moving? Well, up above, we know it's moving if the slope is anything other than 0. Down here, we know the object is moving if the y value is anything other than 0. If the y value is not equal to 0, you have motion. In other words, the reverse question, how can we tell if the object is not moving? If there's no motion, this is what the graph is going to look like. The y value will be 0 right here on the x-axis. On this graph, this is the only place where there is no motion. Everything up here, you got motion. Everything down here, you got motion. So if the y value is anything else other than 0, anything positive, anything negative, we got motion. How can we tell if the object is going forward or backward? Once again, forward is positive, backward is negative, or we can consider it that way. So we're going to say that if the y value is positive or negative, that's how we know. Again, same answers to the questions we had up here. I know I haven't written this down, but you should have those in your notes or it's in the previous video. If the y value is positive or negative, positive direction, negative direction. Let's just consider this graph for a minute, and for right now, let's just imagine that this is a velocity versus time graph, that right here the word velocity appears. So if this is a velocity versus time graph, I want to try to answer 2 questions for each of these segments. And those questions are, number 1, what is the direction of motion? And number 2, what is the speed? So first of all, I want to let you know that the reason why there's no axis here is I want to be sure that that is the first thing you need to determine when you're looking at a motion graph. You can't tell me anything about what's going on if you don't first of all know what kind of graph it is. So that's the first thought that has to come into your head. What kind of graph is this? If it's a position time graph, the next thought that needs to enter your brain is I'm looking at the slope. For this graph, we're going to consider that it is a velocity versus time graph. And if it's a velocity versus time graph, the next thought that enters your mind then is y value. We're looking at y value here. So what I want you to do for each one of these segments, based on what we know about the y value, I want to determine if the direction of motion is positive or negative in that segment, and if the speed is increasing or decreasing or constant. So let's do A first of all. A lot of people look at A and I say, is the direction positive or negative? And they say positive. And I go, great, I agree with you. Why? Many people will tell me that the direction of motion in A is positive because the slope is positive. And it's really difficult when you're looking at a velocity time graph. The most important thing, or the most difficult thing, is to get out of position versus time mode. So when we're looking at position versus time, we get really used to looking at slope. But I don't really care about the slope on a velocity versus time graph. So if this is a velocity versus time graph, I actually do agree with you that the direction of motion in A is a positive direction, but it's not because the slope is positive. The reason why the direction of motion is positive is because on a velocity time graph, we're only looking at the y value. And the y values for segment A are all positive. In fact, the first thing I would do on a velocity versus time graph is circle everything above the x-axis and tell myself that it's all moving in a positive direction. All of A, B, and C are all positive direction, no matter what they look like, because the y values are positive. And likewise, everything below the x-axis, E, F, and G, are moving in a negative direction because we have negative y values. So direction for velocity versus time, this question is answered by looking at whether the graph is above the x-axis or below. So for A, it's moving in a positive direction because the y values are positive. All these questions need to be answered in terms of y value for velocity versus time. And we can answer these questions in terms of the slope for position versus time. Y value right now because we're going to consider this as a velocity versus time graph. So in A, we have positive y values, positive direction, positive velocity. The speed, is the speed increasing or decreasing or remaining constant? Well, we need to know that, let's get my pen here. If the speed is increasing, think about your car. If your speed is increasing, your speedometer goes away from zero. If your speed is decreasing, your speedometer will go toward the zero. But if your speed is staying constant, if it's remaining the same, go to class, bell's ringing. Actually, I think that's the lunch bell. If your speed is constant, your speedometer will stay at the same number. So that needs to happen with the y value. If your speed is increasing, the y value will move away from zero. If the speed is decreasing, the y value will move toward zero, approach zero. And if the speed is constant, the y value will remain constant. So actually, I don't think I need the marker on this. Let's get rid of that. So in A, this y value is actually moving away from zero. These y values are getting greater and greater and greater. So for A, we would say that the direction is positive because we have positive y values, and the speed is increasing. So in A, this car, or whatever it is speeding up in a positive direction. Might be to the right. Speeding up while moving to the right or moving forward. Speeding up. So I want you to answer these two questions, maybe pause the video for a minute and answer both of those questions for each of these other segments, and then come back and we'll talk about them. All right, we're back. Segment B, you should have said that direction is positive, as we said before, because the y values are above the x-axis, positive y values, and the speed here is actually constant. And a lot of people will say that this thing is stopped. If you say that this was stopped, you went back to thinking about slope, because the slope here is zero. I don't really care about the slope there. I care about what the y value is doing. The y value is not zero, so it's not stopped. And the y value is also not changing. So what happened is this thing is speeding up in a positive direction, and now it's staying at the same speed in the positive direction for B. So direction positive, speed constant. For C, direction still positive, but now we are slowing down. The speed is decreasing because it is approaching zero. Now the speed gets to zero, we are not moving at all. The only place where we have no motion on this graph is when the graph is on the x-axis. Y value 0, speed 0. Direction is neither negative nor positive. So speed up to the right, constant velocity to the right, slow down, still going to the right. So maybe we came to a stop in our car. E, negative direction because we're below the x-axis. It's important that you understand that that's the reason why the direction is negative, not because the slope is negative. Because the slope of G is positive, but it's still moving in a negative direction because the slope doesn't matter for a velocity versus time graph. So negative y values, negative direction. What's happening here? A lot of people get these mixed up. Is this speed increasing, decreasing, or staying the same? A lot of people want to say the speed is decreasing because they quote unquote say it's going down. Those y values are getting farther away from zero. The zeros here, they're leaving zero. Whether you're going forward or backward, your speedometer is leaving zero if you're getting faster. So this is negative increasing velocity. So this car maybe is going backwards and speeding up. We're increasing our speed. Our speed is going away from zero. At segment F, don't tell me that it stopped. If you tell me that it stopped, you're looking at the slope again. Don't look at the slope. What is the y value doing? Well, the y values are negative, so we have negative direction. We're still moving backwards, and the y value is constant. So now we have constant speed, so negative constant speed. So we're moving backwards and speeding up, moving backwards and going at constant speed. And now we're still going backwards in G because the y value is negative, but now the y value is approaching 0. So this speed is decreasing. It is slowing down. So we sped up forward, constant speed forward, slowing down going forward. We're stopped. Speeding up in reverse, constant speed in reverse, slowing down in reverse, and then in H we once again come to a stop. Really important to know how to analyze this graph in terms of velocity versus time.